Good morning, class. Today we're going to look at composition of functions. So we're going to start off with a very basic function right here, f of x equals 2x squared minus 5x. And what we're going to be looking for is finding f of negative 4. So what you need to remember, going back to transformations, that whenever you have parentheses, remember that whatever's inside is going to represent x, your horizontal. So negative 4 is going to represent x. So they're asking you to find the function, the value of the function f when x is negative 4. So going back to function f, we're going to put negative 4 into the function everywhere we see an x. We're going to plug in negative 4. Notice I'm putting the negative 4 into the function. It's replacing the x. Everywhere I see an x, I'm putting in negative 4. So we're finding what this function value is, which would be y. Remember that f of x is equal to y. Okay? So now we use PEMDAS, so parentheses, so there's nothing to do inside the parentheses or grouping symbol. Okay, exponent, so negative 4 squared, which is going to be 16, because a negative times a negative is a positive. Okay, so we've taken care of any grouping symbols, we've done exponents, now we're doing multiplying and dividing from left to right. So 2 times 16, and negative 5 times negative 4 is positive 20. When we take care of any adding and subtracting from left to right, we end up with 52. So when x is negative 4, y is 52. So we could say that a point on this parabola is negative 4, 52. Okay, let's take a look at the next example. So here we're given two functions. We have function m of x, which is a parabola, and we have function n of x, which is a linear function. And what we want to find is m of n of negative 1. So when you have multiple grouping symbols, you always begin in the most inner parentheses. So we're going to start off with taking this x value, and we're going to put it into function n to begin with. So negative 1 is going into function n first, and we're going to find the function value for function n. So we have negative 3, plugging in negative 1 in for x, everywhere we see an x. So our function value is going to be 3. So now what we have here is m of 3. So when we plug negative 1 into n, we got out 3. So the value of the function when x is negative 1 is 3. So now we have to take the function value, which is now the input for function m, and we're going to plug it in here. So 1/3, 3 squared minus 4. Order of operations, grouping symbol, nothing to do inside, exponents, multiply and divide from left to right, 1/3 times 9. A third of 9 is 3. And so our final answer, 3 minus 4, is negative 1. So m of n of negative 1 is equal to negative 1. Okay, example 3. Here we have function c, which is linear, and we have function g, which is also linear. And we have two different notations. You need to be familiar with both of them. Okay? So this one makes the most sense to me. Here we're plugging x into g. Well, it's already in there. Okay, so there's really nothing to do here. And then here we're plugging, now remember, whatever's inside the parentheses is going to represent x. So g of x, so this function right here, g of x, gets plugged into function f as x. So we're taking this function g, 3x plus 2, and we're going to put that function into f. And I should have used c, sorry about that. I know, Ozzy, I know you caught that right away. But we're going to plug 3x plus 2 into function c everywhere we see an x. So here we go. So 2, and then x. So what does x represent? X is g of x. So we're going to put 3x plus 2 minus 1. Notice the x in this function has been replaced with g of x, which is 3x plus 2. And then we simplify this, so we're going to distribute. Bring down the minus 1 and continue to combine like terms. And that's as far as we can go. So this would be our answer. So c of g of x, we're plugging g of x into c and simplifying it, we get 6x plus 3. Notice that the most inner was an x, so the answer is going to also have an x in it. Okay, whereas this example up here, the inner was a number, so we were able to calculate a value, a number for an answer. Now this notation here means the same thing. Okay, we're taking g of x and we're plugging g of x into function c. I like this notation better, but you have to be aware that this notation is also relevant and you need to know it. This function here on the end gets plugged in to function c, and that's what we did right here. If this is confusing, please ask me in class and I will go over it with you again. I hope you guys are having a good night, and I'll see you in class.